What is a floaty animation?
Before I tell you what is a floaty animation, let's watch this animation. And next, I will show you another example. Now, did you notice any difference? Yes. One of them, the first one that I showed you, was really very slow. Now, coming to the question that we asked at first, what is a floaty animation? A floaty animation happens when the timing is really slow and the animation looks very floaty. Now, the question is, how can it be solved? Well, as you know, I have said the main problem is the timing. So we need to adjust the timing of the animation. Now, if we go back to the traditional animation and if you think like this, in order to do a 2D animation, a hand-drawn 2D animation, you had to draw all these 50 frames of going back. Could you imagine it? You would never like to draw it. So thus, you would draw lesser drawings, and thus there will be hardly any problem with the timing. In order to have a better timing, you can't really decide one final time that this is my keyframe and I will animate till this one. You have to experiment it. You have to go forward and backwards in order to see if your animation is really at the right place. In this animation, we'll first watch the hammer, which is which goes back really slow, and the whole motion is slow as well. So let's check how many gaps of frames does it have in order to go back. It has 50 frames to go back and another 40 frames to come back and another 150 frames to just come backwards and then to move forward another 20 frames. That makes it really slow. Now let's go and watch the animation that is faster. So in this case, the hammer goes back in just 15 frames, then moves forward in 25 frames, and then goes back in another 25 frames, and then comes in front where it tries to hit the ball. It just takes a gap of one frame and then hits on the ground, and then bounces back, which has just a gap of one keyframe for each. But for the slow animation, even the bouncing has a larger gap of keyframes than the faster one. So that makes the hammer movement very slow. Now let's come to the ball. The ball reacts to the action very slow as well. Let's watch the animation again. The ball is reacting to the hammer very slow as well as the hammer. So when it jumps up, it doesn't look like as if it is jumping really fast in order to save itself. That's what the action means. So the weight of the ball is also not clear because of the timing. But if we see the faster animation, you'll understand that the ball has a weight and it reacts to the hammer quite fast. So you know the lesser the number of frames, the faster the animation is. You can also adjust your animation using the curves. Here there are loads of curves option where you can use simplify curve, Euler curves, and you can also adjust the curves manually. So here as you can see my curves are not the usual way it should be. So I did manipulate the curves a bit in order to have a good action. If you see over here, the hammer goes back and waits for a little while and then comes in the fast speed. So in order to create that, I used curves. I did not do it manually. In order to have a good timing for your animation, you need to visualize the action or the animation very nicely. You can also watch references, and if there is no references, then you can act it out yourself in order to see how the actual timing goes. That might help you to make the timing faster. So these are small tricks that you can apply in order to make your floaty animation not floaty. And always remember one thing, that in traditional animation there isn't any floaty animation because people don't draw so many frames. Since this is a software that allows you to drag as many frames as you want, you need to be very careful in that case. Hope you enjoyed the video. Thank you for watching.
To learn more about animation, watch our other videos.